Greetings, fellow cosmic voyagers. Today we're embarking on an exhilarating journey to Mars. Is Mars really our next home? How much do we truly understand about this world? We'll uncover 10 mind-blowing facts about Mars. Strap yourselves in, because we're about to launch into a Martian odyssey. Don't forget to like, share, and subscribe. Now let's venture to Mars. When you picture Mars, you probably imagine a static, unchanging, frozen desert, right? But Mars, much like our own Earth, experiences the distinct ebb and flow of 4 seasons. This isn't just a vague similarity, it's a fundamental aspect of its planetary character. Mars is tilted on its axis at approximately 25.2 degrees, similar to Earth's 23.5 degrees. This tilt causes different parts of Mars to receive more direct sunlight at different times of its year, leading to these seasonal variations. Spring might see the retreat of polar frost, revealing the darker ground beneath. Summer means longer days and slightly warmer temperatures, while the other hemisphere experiences winter. Understanding these seasons is crucial for future human explorers or robotic missions, affecting everything from atmospheric dynamics to choosing landing sites. The Martian seasons are a constant reminder that while alien, Mars shares some fundamental planetary physics with Earth. Now let's shift our gaze to something monumental. Mars is home to Olympus Mons, the tallest volcano, and indeed the tallest known mountain in our entire solar system. Olympus Mons stands at a staggering 13.6 miles, or about 22 kilometers high. Its base would cover an area roughly the size of the state of Arizona, or the entire country of France. If you were standing at its summit, its slopes would extend so far that they would disappear over the horizon. The leading theory for its formation points to the lack of active tectonic plate movement on Mars. This allowed a plume of magma to continuously feed the same spot on the surface for an immense period. The lower surface gravity of Mars also played a role, allowing the volcanic construct to grow taller and wider without collapsing under its own weight. Olympus Mons is a testament to Mars's ancient volcanic activity and a window into the planet's internal processes and geological history. Let's turn to something more relatable. The day length on Mars. A day on Mars, or a sol, is remarkably close in duration to our own Earth day. A Martian sol lasts 24 hours, 39 minutes, and 35 seconds. This similarity in day length has profound implications, especially when we dream of human presence on Mars. Our bodies are deeply attuned to a roughly 24-hour cycle, known as the circadian rhythm. The fact that a Martian sol is so close to an Earth day means that humans could adapt to a Martian day-night cycle with relative ease. NASA scientists and engineers working on Mars rover missions already live on Mars time when missions first land. This temporal similarity is already being leveraged, making Mars just a little bit more hospitable to human endeavor. Every planet has its celestial entourage, and Mars is no exception. Mars plays host to 2 much smaller, more enigmatic companions, its moons, Phobos and Deimos. Phobos and Deimos are tiny by planetary moon standards and are likely captured asteroids. Phobos orbits incredibly close to Mars, just about 6,000 kilometers above the surface, completing an orbit in a mere 7 hours and 39 minutes. Deimos, being further out, has a more leisurely orbital period of about 30.3 hours. The ultimate fate of these tiny moons is also a subject of scientific fascination. Deimos is slowly drifting away from Mars, but Phobos is on a collision course. These little moons are dynamic laboratories for understanding orbital mechanics, planetary capture, and the long-term evolution of celestial bodies. Of all the questions we ask about Mars, perhaps none is more compelling than the question of water. The evidence for Mars's ancient watery past is now overwhelming, etched into its very landscape. Our orbiters have mapped vast, dried-up riverbeds, and rovers have driven across what were clearly once lake beds. Much of the water was likely lost to space as Mars's atmosphere thinned over eons, but not all of it vanished. A significant amount of water is still present on Mars, locked away as ice. Recent missions have provided evidence for what might be large reservoirs of salty liquid water brines buried deep beneath the southern polar ice cap. This discovery of potential present-day liquid water reopens the possibility that microbial life might still persist in these sheltered subsurface environments. The search for water on Mars is inextricably linked to the search for life, past or present. When we think about what makes a planet habitable, Its atmosphere is right at the top of the list. The Martian atmosphere is incredibly thin. Its surface pressure is only about 0.6% of Earth's mean sea level pressure. It's overwhelmingly carbon dioxide, about 95.3% CO2. Despite its thinness, this CO2-rich atmosphere is not inert. It's dynamic enough to support weather phenomena. The thinness of the atmosphere also means it's not very good at trapping heat, which is a major reason why Mars is so cold. Understanding the current state of Mars's atmosphere is the first step in any plausible terraforming scenario. It's a critical piece of the puzzle, whether we're planning short-term robotic missions, long-term human habitats, or dreaming of a future greener Mars. It's a constant reminder of the delicate balance that makes a planet habitable. Mars's thin atmosphere can stir up the fine Martian dust, leading to formidable dust storms. These storms can start small but can grow into regional or even global phenomena. Imagine a dust storm so vast that it blankets almost the entire planet, obscuring the surface from view for weeks or even months. The Great Dust Storm of 2018, for example, was a planet-encircling event that led to the demise of the Opportunity rover. The dust itself is incredibly fine and gets everywhere, posing a significant operational challenge. Understanding the physics of how these storms initiate, grow, and dissipate is a key area of Martian meteorology. For future human colonists, these storms would be a serious environmental hazard to contend with. While these storms are a challenge, they are also a fascinating aspect of Mars's dynamic climate system. Mars exerts a weaker gravitational pull on everything at its surface, approximately 38% of Earth's gravity. If you weigh 100 pounds on Earth, you'd weigh only about 38 pounds on Mars. This reduced gravity might sound like fun, but for long-term human habitation, it presents serious physiological challenges. Muscles can weaken and lose mass over time, and bones can lose density. Astronauts on the International Space Station already face these issues and combat them with rigorous daily exercise regimens. Similar countermeasures would be essential for colonists on Mars to maintain their physical health. Understanding and addressing the long-term health implications of living in 38% gravity is one of the critical hurdles to overcome. It's a fascinating interplay between physics, biology, and engineering. Could Mars truly be our second home? According to passionate advocates like aerospace engineer Dr. Robert Zubrin, it's not just possible, it's imperative. Zubrin champions the idea of living off the land, or in situ resource utilization, ISRU. This means using the raw materials readily available on Mars to produce essentials like fuel, water, oxygen, and even building materials. NASA's Perseverance rover has an instrument called MOXIE that has successfully demonstrated it can extract oxygen from the Martian carbon dioxide atmosphere. Companies like SpaceX are heavily investing in the technologies needed to make this a reality. Mars, with its almost 24-hour day, its available resources and its potential for eventual terraforming, stands out as the most viable candidate for humanity's first off-world settlement. The idea is shifting from if to when and how. Mars might just represent humanity's next giant leap, a step towards becoming a multiplanetary species. Humanity is not just idly dreaming of Mars, we are in an incredibly active phase of Martian exploration. NASA's Perseverance rover, which landed in Jezero crater in February 2021, is searching for signs of past microbial life. Perseverance is collecting promising rock core samples for a potential future Mars sample return mission. Its companion, the Ingenuity helicopter, made history by performing the first powered, controlled flight on another planet. Orbiters like NASA's Mars Reconnaissance Orbiter and ESA's Mars Express are constantly mapping the planet and studying its atmosphere. SpaceX is aggressively developing Starship, a fully reusable super heavy lift launch vehicle designed to carry humans and large amounts of cargo to Mars. Each new discovery and technological demonstration brings us a step closer to the day when human footprints will join the rover tracks in the Martian dust. We are systematically, scientifically, and passionately getting ready to go. From Earth-like seasons and colossal volcanoes to whispers of water and human colonization, is Mars our next home? Mars offers resources, a compatible day length, and a frontier for human exploration. It depends on our investment in science and technology and global collaboration. With innovation and determination, Mars could be our next giant leap. Subscribe to Knowledge Panel for more cosmic adventures.